Hello and welcome to this video. In this video we are going to take a look at how we can build a system for something like Uber or Lyft. These applications are highly sophisticated, and keep in mind that we will never know how they are getting designed and built because they are private companies and they spend multi-million dollars on their systems. So take this video with a grain of salt. This is not the exact way of implementation of such those systems, but it will give you a good understanding of how they might work. In today's world, which is getting increasingly connected, ride-sharing systems and platforms have revolutionized the way we think about the transportation. These platforms offer an efficient, cost-effective, and convenient alternative to traditional taxis and car ownership. However, building such a system is complex and requires a deep understanding of various domains, including the mobile app development, the real-time data processing, secure payment integration, and the scalable system design. In this video is kind of a detailed guide on such a systems. We will explore the fundamental components and the functionalities necessary to build a comprehensive ride-sharing platform. We will walk through the user requirements for both the rider and the drivers. We discuss the architectural decisions, and we will examine the various services and the components that interact to one another to enable a seamless ride-sharing experience. The fundamental requirements are we want to have a rider, the ETA view and pricing, the payment, and the driver details, and the real-time tracking. In the rider, this is what we need from the riders information. The location selection part, the riders should have an intuitive interface to pick a location on the map. This usually achieved through the integrated map services like Google Map or Mapbox. About the viewing the ETA and the pricing, after selecting the location, the system calculates the ETA using the algorithms that factor the current traffic, roadblocks, and the nearest available driver. The pricing module calculates the cost based on the factors like distance, surge pricing due to the demand, and other dynamic factors that it is different for each country and city and location. About the payments for the riders, once the riders decide to book a ride, they should be able to pay using various payment gateways. Is something very important in here. Payment details should be tokenized and never stored in a plain text, and the driver's details that we need for the riders. Upon the ride confirmation, riders should receive the comprehensive driver information, including the car make, model, color, the license plate number, and the driver's photo, and the easy identification information. And about the real-time tracking that the rider needs to see, the rider should be able to track the driver location in real time until they reach the pickup point. And about the driver needs two main things to consider: the ride request. The driver receives the ride request based on the proximity, availability, and other factors, and their rating. Of course, they can accept or decline these requests. And about the navigation, upon the accepting the request, drivers should turn-by-turn navigation to the pickup point and subsequently to the destination. About the system design and the system architecture, first let's talk about the database. The profile needs to be stored in the database. Details about both drivers and the riders, including their rating, previous trips, and the preferences. And the trip information also needs to be stored on the databases that we have. The information about ongoing and past trips, including the trip start and the end time, and the location, charges, and associated driver, and the rider ID and the driver ID, and all sorts of information that is related to this scenario. It is dependent on the company's situation and the company desires. And the service-oriented architecture, which is the map, ETA service, pricing service, the payment service, and the matching service. So let's take a look at each and every single one of them. in detail. The map service renders the map, calculates the routes, and offers the geocoding, converting the address to latitude and longitude. ETA service is based on the current traffic conditions and the driver's location. It provides an estimated time of the arrival, and the pricing service works dynamically, adjusting price based on the demand, and the time of the day, and the other factors that need to be considered. And again, these are something that the company should decide. And the payment service handles the transaction. It should be robust, secure, and support multiple payment methods for the ease of use of the user. Moving on to matching service, this is a complex one. Users should be calculated on an algorithm to match riders with the suitable drivers based on the various parameters. So this particular part needs an entire team in development sometimes. And we have the event bus, which is using Kafka. This is vital for decapulated architecture. Services publish and subscribe to events, allowing for real-time communication without direct dependencies. And we need robust APIs for such an application to handle the immense load of such a system. The system needs to have a scalable API for both riders and the drivers. We need to consider the load balancing and distributing income traffics across multiple servers to ensure a single server is not overwhelmed. And WebSockets are something very important. Instead of traditional HTTP requests, which are stateless, WebSocket provides a full duplex communication channel. This allows for real-time location update without consistent pooling, redundancy, latency, and server load. We need to consider optimized database design. Given constant flow of data, the databases need to be optimized for both read and write operations. Sharding needs to be considered. The distributing data across different servers and the clusters. Shared keys are pretty important, like user's ID. The driver's ID help us in evenly distributing data and managing the data. And we need to have global indexes to speed up the data retrieval, especially for frequent query patterns. For instance, fetching ongoing trips for a specific driver or rider. And we need to consider the external integration. Leveraging established services can help us save time and ensure the robustness of our application. The map service, in particular Google Map or Mapbox, provides us with a very good map for rendering, geocoding, and sometimes even the ETA calculations. And the payment gateway needs to be something very well known and with the very high uptimes, like a Stripe, with the webhook mechanism that we can notify our systems once a payment is processed. And we need to consider the dynamic pricing model to adjust prices based on a demand. A real-time streaming pipeline like a Spark integrated with the Kafka can help us analyze ride requests and adjust our prices in a real time accordingly. And we need to have efficient driver location system in mind. The H3 algorithm can help us in this case by dividing the world into hexagonal grids. It simplifies the task of finding drivers in a particular area. And to have a comprehensive overview of what I just said, from the rider's perspective, the process involves selecting the location, viewing the ETA and the price, confirming and making the payment, getting the match with the driver, and receiving the driver detail and tracking them in real time. There are advanced considerations to keep in mind: the scalability and the redundancy. As the user base grows, the system should be scalable without compromising performance, redundancies, and ensuring the service continuously keeps operating without a case of failure. And there are advanced algorithms that need to be implemented for such a systems. Custom algorithms should enhance the ETA prediction and the driver ride matching. And the data analytics is pretty important for such a companies. Analyzing the trip data can offer insight to improve the services and spot the trends, and helps us with determining the prices. And the geographical sharding, it's very important because we need to store data closer to where it's frequently accessed and sped up to retrieve times. And building such a system like Uber requires a combination of robust technologies, user-friendly design, and continuous continuous optimization, and most importantly, senior developers that have these types of experiences and they understand the systems. It needs a dynamic process that involves with the user needs and the technological advancements and the business goals. So building a robust and a scalable ride-sharing platform like Uber is a significant undertaking that involves a lot of components to work together in a harmony, and they need to be orchestrated from the initial rider request to payment processing and the driver management. Every step is underpinned by a complex algorithm, real-time data processing, and a focus on user experience. And the scalability and the resilience are not just buzzwords, they are fundamental to ensuring that the system can grow and adapt to an ever-increasing user base and the unexpected failures. Furthermore, the external integrations with the map and payment services are a key for focusing on the core business logic while leveraging the proven solutions for complex tasks. As the technology continues to evolve, so too will the architecture of such a system, and the demanding increases and the commitment of the developers plays a key role to the functionalities of such a system. Ultimately, the goal is to create a secure, efficient, user-friendly platform that stands up for the demand of the modern transportation needs. So that's it for this video. I hope this video was informative to you and it give you a good understanding of such a system. I hope I provided you with the useful information. Thanks for watching, and I will see you in the next video. Hello and welcome to this video. In this video we are going to take a look at building a scalable web search engine. This is a system design course and is meant to give you an overall perspective of such a system implementation. So in today's world of digital era, search engine serves as the cornerstone of internet navigation, acting as a digital library. They help users to shift through the extensive web to find a specific information. This guide aims to present a comprehensive and detailed blueprint for constructing a web search engine on a scale of industry giants like Google, and we will delve into the interactics involved in each component, from processing user queries to crawling the internet while maintaining efficiency and scalability. First thing that we are going to take a look is a search API, the user gateway. So we need a repository to accept the user search request and return a list of relevant results. And we need functionality to contain the process search queries, communications with the backend database to fetch the result, and we need load balancing for distribute income network traffic across multiple servers, each with the high availability and readability. And we also need pagination to allow users to navigate through the result in a structured manner, avoiding information overload. The second thing we need is a database and a blob store, which is our information reservoir. The database needs to have responsibility to store metadata such as URL, title, description, hash to ensure the uniqueness, and last updated date, and priority for crawling. It needs to have the sharding, which is a method to distribute data across multiple machines, enhancing the scalability. And our database need to have global indices, which is a specialized structure for efficient searches by hash and word. Our blob store again needs to have the responsibility to hold the raw content of a website, and our distributed storage should enable us to get efficient and scalable storage of massive data volumes. And we need a reference storage. Instead of storing the actual content in a database, a reference link to the content in the blob store is kept in the database, creating a separation between the metadata and the actual content. The third section that we are going to take a look at is web crawlers, which is the internet explorers. Web crawlers should have responsibility to navigate the internet, to discover and download pages page content. Their functionality should be that they need to fetch pages, extract new URLs from these pages, and add them to the URL frontier. Scalability and efficiency comes as a very important point for crawlers, which two things must be considered in the scalability and efficiency. We require massive parallelism, hundreds of thousands of concurrent crawlers, and the geographical distribution to optimize the latency and the balance and the bandwidth. The second thing in the scalability and efficiency is to keep in mind the respects to the robots.txt files on the website to avoid overloading or accessing restricted areas. The fourth section is the URL frontier, the scheduler of the crawlers. The responsibility is to manage the queues of the URLs that need to be crawled, and their functionality is to ensure the politeness, which means that they should avoid overloading the hosts, and the priority, which is the frequent crawling of high priority sites. So the priority needs to be considered for the URL frontiers, and the implementation part is that, and about the implementation part, multiple queues stored by the priority and the host should be implemented to balance the crawl load and respect the robots.txt rules of the website. The fifth section that we need to consider is challenges and the advanced consideration that includes the storage and bandwidth constraint. Managing the petabyte of data of high bandwidth usage requires an intuitive storage solution and a network management. So these systems are quite expensive, and the fault tolerance and the recovery must be kept in mind for such a scenario. Designing the system to recover gracefully from the hardware and software failures without data loss or significant downtime, and the handling the near duplicate pages. The efficiency of identifying and managing pages that are very similar but not identical using the technologies like shingling must be implemented, and efficient indexing and ranking algorithms plays a crucial role in such a system. Implementing an advanced algorithm such as PageRank or rank the page by relevance and importance. So this is a quite sophisticated topic, and we must perform a personalization and user behavior analysis for such a system to work properly, adapting search results based on the user behavior and references, and ensuring the user data privacy. Moving on to the security and anti-spam measures. This is a crucial part of the system because the system can be taken down by such a malware. Implementing a security measure to prevent the system from various forms of cyber attack and filtering them out or low quality content. And the legal and ethics of such a systems are quite important, respecting the copyright laws and user privacy and other legal norms while crawling and indexing the web is pretty important, and sometimes the companies might get into trouble without implementing an ethical consideration. The monitoring and logging plays again a pretty big role in this scenario. Continuous monitoring of the health of a system health, performance matrix, and the comprehensive logging for debugging and analysis is pretty important, and the geographic distribution of servers and data centers must be implemented to offer a low latency service for worldwide usage. And building a search web engine involves a complex blend of computer science principles, including the distributed system, the databases, the networking, and the algorithm, which is highly sophisticated and sometimes has a very difficult problems to solve. And building a web search engine emphasizes the interactives and challenges at each steps, from the search API, database or blob storage, web crawlers to the URL frontier. Each of these are pretty difficult to implement and design, so there are hundreds of developers or a couple of hundreds might work together to build such a system, and they are pretty expensive. And in the dynamic realm of internet, search engines are disputable tools. The journey towards creating a faster and more precise and user-friendly search engine is a vibrant and rewarding field, inviting innovators to continuously push the boundaries of what is possible. So I hope this video was informative to you, and this video was a quick overview of such a system. Thanks for watching, and I will see you in the next video. Hello and welcome to this video where we are going to discuss the payment gateway system design, which is a crucial aspect of any e-commerce or money-making platform nowadays. A payment gateway system facilitates online transaction between the customers and the merchants. It acts as a middleman, securely transferring sensitive information between the buyer, merchant, and the bank. There are a couple of things to consider for designing such a system. First category that we are going to take a look at is handling request timeouts, which is very important. The importance in these situations lies where a request timeout occurs. The actual payment status becomes ambiguous, and the customer perspective should clearly communicate with the request status to avoid confusion and possible double charges. And the strategies to take for such a scenario is set timeout high enough to allow a slower response, low through to avoid waiting indefinitely for a response. The next category to keep in mind is idempotent transactions. The concept is the idempotent operation have no additional effect if called more than once with the same input parameters. The implementation is to use a unique idempotent key commonly used for a UUID that is generated by a client and added to the HTTP header, and the use of the idempotent key to identify and manage retries, preventing double charges, and employ databases constrained to detect the duplicate request. The next category to consider is error handling and the resilient. We need to have a fallback pattern to allow services to communicate with web-dependent services, for example a project service, if it fails, and in the event of the internal service error, rather than aborting the whole computation, filling the fallback value. And the business roles as a fallbacks are something to consider for a smaller amount. We should consider allowing transaction to proceed dispute service failure, balancing the risk with the customer satisfaction. And the next category to consider is persistent failures, which basically, if you don't know, it is the message that will always fail due to incomplete data between the sender and receiver, and the isolation problematic message must be implemented as well to save failed messages in the dead letter queue for later inspection and debugging. And the next category to consider is handling the system downtimes. The persistent queues are going to come in handy during the service downtime. We should store transaction in a persistent queue, process these transactions once the failed service recovers, and all of these sections that I'm mentioning, they have a lot of details that needs to be considered while implementing a real-world scenario, and distributed system consideration are a big part of designing a payment gateway nowadays, because the redundancy should be achieved using replication, and the multiple copies of data and processes provide a backup in a case of component failures for us, which is pretty good if we have a backup. And the scalability is easy, ability to scale up or down by adding more or removing components if necessary or needed, and the data consistency in a distributed system and the communication failure between the nodes can cause inconsistency and replication lag. And be aware of consistency level used during the read and write operations. So the data consistency is a challenge, and the data security, which is the most important part of any payment gateway, has its own section of design, and one of the experts should design this part. The encryption plays a crucial role. Data at rest should be implemented to convert data into secure format which is unreadable without a key, and data in transit must be implemented, and it means that employ the protocols like VPN, TSL, and HTTPS, and these types of secure and encrypted data transfer methods should be implemented over our network. And the access control in the security is again pretty crucial to restrict data access to authorized users only, and implement two-factor authentication for additional security. And the regular updates must be added to the system to keep all the software and operating system updated with the latest security patches. And the data backup is a backbone of these types of systems, and they should regularly back up data to recover in a case of loss or damage, making ransomware attack less damaging. And the password policies for the users are pretty important to encourage users to set a long, complex, and uppercase or using different keyboard signs in a password are pretty nice to have, and users should create a unique password to defend against the rainbow table attacks. And the data integrity and monitoring such as systems are not that difficult to check for unauthorized changes in important data files by generating cryptographic checksum as a baseline and recalculating and comparing this checksum and the regular interval, generating security alert in a case of discrepancies. Overall, building a payment system requires thorough planning and robust strategies for handling request timeouts, ensuring independent transactions, and managing errors gracefully, and securing sensitive data. By adding these considerations, the payment system will be well equipped to handle various challenges and provide a reliable service. So this was, I think, a good real-world overview for a payment gateway system. I hope this video was informative to you and you learned something from it. If you learned something from this video, make sure to leave a thumbs up button or subscribe. Thanks for watching, and I will see you in the next video. Hello and welcome to this video. In this video we are going to take a look at how we can build the authentication system, and this video is an overview on system design. So if you are interested in system design, I will cover everything you need to know about implementing such a system. Authentication is a fundamental component in securing digital services. In a realm of web services, JWT or JSON Web Tokens have become a popular means of verifying and authenticating users. This video explain in detail the design consideration for implementing an authentication system with usage of JWT. First thing that we want to consider is JSON Web Token issuance on login. In the beginning, the request and response are something to consider. When a client logs in, the server issues a JWT. This JWT is then returned to the client and stored locally. In the second stage, the data integrity using the asymmetric encryption must be taken into consideration. Whether the client requests an access to predict the endpoint, which is the user endpoint, it sends it to the JWT. The server utilizes the asymmetric encryption to ensure the data integrity. Through the JWT signature, the server can verify that the header and the payload organized from the authenticated login service, and this third thing that we need to consider in the JWT logging part is handling tampering. If an attacker modifies the JWT payload, changing the username, for example, to the desired username that he wants, it should not match the signature. Such modification will result in failed integrity checks, leading the server to reject the authorization attempt. And the second subject that we need to consider is security consideration, because authentication is all about the security, and one of the best ways is decentralized authentication. The outline approach, it should be decentralized, eliminating the need for frequent database check on authentication. However, it's a very critical and crucial secret to guard, especially the encryption algorithm used must be sufficient and sophisticated. If leaked, malicious actors could potentially forge the JWT, bypassing the login procedure, and find out the weaknesses of the algorithm. And the second thing in the security consideration part is human factor in security. Human error remains a significant security vulnerability, for instance, inadvertently revealing the encryption method that can compose the entire system. The third thing to consider on security is central control versus decentralization. Decentralization system offers benefits of quickly revoking access for all users should the need to arise. For instance, if an API handles both logging and logout, the logging out could trigger the status change in a central database, with the JWT token remaining valid until their expiration. Even if the user logs out, this longevity means protected endpoints must honor the token until it expires. The centralized system is kind of good for some scenarios. A common solution to these types of challenges is embedding the token expiration within the JWT payload. If the current time surpasses this timestamp, the JWT should become invalid, and these types of methods should be implemented on each and every single system. And the fourth thing to keep in mind while considering the security, it is the importance of a state in authentication. To efficiently implement authentication, maintaining a state is essential. Highlighting this is crucial during the discussions about the system design in interviews or planning phases. The decentralized authentication can reduce database load, but careful consideration must be given to security implications. And the fifth thing is the client trust. Always approach client data with security first mindset. The data in the hands of users is susceptible to tampering or interception by malware actors. Ensure the encrypted communication channels such as HTTPS, and understanding the importance of HTTPS or other security protocols is paramount to maintaining data integrity. While authentication might appear simple at first glance, its interactics lies in detail, striking a balance between the user convenience, system efficiency, and security is a challenge but very essential thing to do in a modern world. When building or discussing authentication system, especially in a larger scale microservice architecture, it's vital to emphasize state management and the potential vulnerabilities when the data is entrusted to the clients. Always prioritize security in decision making, ensuring that the client data is handled with the utmost caution. So that's it for this video on an overview on building an authentication system using JWT. I hope this video was informative to you and you learned something from it and it was worth your time. That's it for this video. Make sure to leave a thumbs up button and subscribe if you liked the video. Thanks for watching and I will see you in the next video. Hello and welcome to this video. In this video we are going to take a look at machine learning system design, in particular about fraud detection systems, which are a crucial part for identifying unauthorized activities across various industries. They have evolved from a role-based system to a sophisticated machine learning models in a today's world, which are capable of identifying complex nonlinear patterns of indecisive frauds. To develop a machine learning system capable of classifying transactions or activities as fraudulent or legitimate based on historical data while minimizing false positives and negatives. And in such a system, we have different objectives, such as to achieve high accuracy rate for fraud detection and to process transaction in real time or near real time. Also, to continuously learn and adapt new fraud patterns. Current system might have limitations like high computational cost or high number of false positives and negatives, and the inability to adapt new fraud patterns. So here the machine learning comes into play. For a good machine learning, we need data sources. We should collect data from internal sources, the transaction logs, the customer profile, and external sources such as blacklist, government databases, and the tools for use for data sources. And skills that a developer needs to have is need to understand the SQL database, the NoSQL database. Pretty much most of the databases, especially nowadays the graph databases, it needs to understand Apache Airflow for streaming data and for data cleaning and pre-processing, which we want to handle the missing values and outline and standardize and normalize numerical values. We need the tools like pandas, numpy, and scikit-learn. Also, something to consider is feature engineering, designing features that are indicative of fraud, etc. We need the transaction frequency, the amount patterns, and for the tool part, we need pandas and feature tools for feature engineering. And there are a lot of tools nowadays, but these two are the most important one. And we need to have a model selection criteria to choose based on the accuracy, the training time, and the prediction time. And the model consideration are logistic regression, decision tree, random forest, neural network, SVMs, gradient boosting machines, or GBM for short, and the isolation forest. And the tools for implementing these algorithms are usually scikit-learn, TensorFlow, and PyTorch, and XGBoost are the most used, but these tools for every project it's going to be different. Every project will use and requires a different tool, and we need also the model evaluation matrices to use the precision, recall, F1 score, ROC, AUC, PR, AUC to evaluate the model. And the tools for that is mainly scikit-learn, which has a matrix module that comes pretty handy. And the system architecture and overview. A typical setup includes the data ingestion pipeline, the data warehouse, a feature engineering pipeline, and the model training pipeline, a prediction API which is used for scoring, and the monitoring and alerting system. And the component design needs to be implemented as well for scalability and maintainability. Components can be concatenarized using the tools like Docker and orchestrated with the Kubernetes, so you should kind of be familiar with that as well. And the technologies to use and the programming languages are basically Python, Java, SQL for backend implementation, and the TensorFlow, PyTorch for deep learning models, Apache Spark for big data processing, AWS and GCP or Azure for cloud deployment. Usually in these types of systems, a lot of tools and software should come in together for such a system to work properly, and the code structure and the organization must follow the MVC pattern or similar structure. It really depends on the company and the research team, and everything should be in separate directories for data processing script, model script, utility scripts, and test. And usually everyone uses the Git for version control nowadays, and it is pretty much the only option. And the evaluation and testing part, we need to split the data set using the techniques such as k-fold, cross-validation, star field sampling, and temporal splitting. And the resulting and the performance comparison needs to be implemented as well to perform A/B testing to compare the new model with the existing system. And the tools for doing that are SciPy or statistical test, and the error analysis. It is one of the most important and crucial points of such a system because you're going to get a lot of errors and you need to fix all of them. And investigating these errors that you're going to encounter, it's a crucial point for making a reliable system. So you need to have the deployment strategy and the continuous development development, which is a CI/CD pipeline. Most of the companies use Jenkins and GitLab CI, and you need to have monitoring and maintenance to regularly check the model drift and retrain the model as needed. Tools are usually Prometheus and Grafana, and if you ever looked at a job description for ML engineering, you will see that most of the companies that are seriously involved in AI usually require Prometheus and Grafana. So the security is also a crucial point, to use encryption and manage access control regularly to maintain the system. And the most used tools are AWS, KMS for key management, and LDAP for access control. And usually these types of systems need regularity and compliance to ensure the system is compliant with the GDPR and HIPAA, etc. These might involve working with legal teams and using the tools and services that provide a compliance certificate, because nowadays a lot of AIs are facing legal issues because of using unauthorized data. And to wrap this video up, every team needs to have researchers to propose solutions for the problems, and it needs to have an evaluation and the testing team to test the result, and they should work together and discuss the potential future work, such as incorporating more data sources or trying different machine learning algorithm, or expanding and being creative and creating new types of fraud detection techniques. And these frameworks aim to cover each section of machine learning system design, and I try to cover everything that you need to know about machine learning system design in this video, but there are a lot of detail to consider. You should definitely read the book named Machine Learning System Design by O'Reilly, which is a pretty good book, and I recently did read it, and it gives you a more complete understanding. But in this video we don't have the time to go through everything, so I hope this video was informative to you and you learned something from it. If you have any question, put it down in the comments below. Thanks for watching, and I will see you in the next video.